Hey, pre-algebra party people, welcome back to class. We're going to continue on our algebraic simplifying journey, and we are going to do a part 2 video on the multiplying monomials lesson. So here we go. I want you to warm up, see if you could find the area of this rectangle that is 5 meters in width by 12 meters in length, and also the next one, which is it looks like a cuboid or a rectangular prism that has a base that is a 3-inch by 3-inch square, and it is 7 inches tall. And you would find the volume of this guy. All right, so go ahead, see if you can figure those two problems out, and we'll talk about them in a second. All right, so the area of a rectangle, if you didn't know from your previous math courses, area is equal to length times width. Now, that seems pretty easy. We're just going to do 5 times 12, right? But what about the units? When you've been in geometry in years past, you've said that anytime that you have an area, you're going to have squared units. And the reason that is, if I actually write this 5 meters, times 12 meters, that results and an area of 5 times 12, which is indeed 60. But what is meters times meters? Meters to the first power times another meters to the first dimension results in not meters in the first dimension anymore, but meters in the second dimension. And there you have it. You have this thing that is in the second dimension called a square meter. So maybe that might make a little more sense to you now of why the meters times more meters becomes meters squared, because what we have been doing with the product rule is we've been having variables that have exponents and we add their exponents. What about if we have a third dimensional problem and finding the volume? The volume is equal to the area of the base times the height. Or for any cuboid, you're just basically multiplying the 3 numbers together. So that's exactly what we'll do. We'll kind of cheat here. Volume is equal to 3 inches times 3 inches times 7 inches. And when I multiply a 3 times a 3, and I can do this out of order if I needed to by the commutative property, 3 times 3 is 9 times 7 is 63. But what's inches in the first dimension times inches in the first dimension times another inches in the first dimension? Well, that's inches in the 1, 2, 3. And there you have it. Cubic inches is your unit of volume here, cubic inches. And we are using the product rule, as was discussed yesterday or whenever you watch the video, to come up with the correct unit for this geometric figure. And before in your math career, you might have said, okay, it's volume. It's just going to be inches cubed, right? And you just had to remember that it was inches cubed. Now it might make a little more sense mathematically why it is inches cubed. But the problem with teaching that to 4th, 5th, 6th graders that they don't understand these algebraic concepts like you do yet. So that's why you just have to say you just need to remember that volume is inches cubed. All right, so let's move on. Let's put it all together. Let's put our algebraic simplifying toolbox tools all together. See if we can do some more complicated operations here today. So, but first we have to throw back to last unit. We have to recall distribution in like terms. So distribution was, when we use the distributive property, was when we've got a factor sitting outside of a group that had terms inside of the group that were being added and subtracted. So if you notice, we're going to distribute that -3 on the outside. We're going to distribute that -3 in this particular case. -3 times x is -3x, and -3 times 7 is -21. So I could add -21, but that's the same thing as subtraction. So my first step is done. But am I done yet? And hopefully you remember enough from last unit, and I was a good enough teacher that you're like, no, we're not done yet. Now we have to find the like terms that match, and I can add them together. Remember putting your dividers up in between each term to make sure that we have the sign of the term correct. So the x terms are like -3x, and positive 5x are like terms and are able to be added, and -21 and negative 3 are able to be added. So negative 3x plus 5x, that should give you a positive 2x, and negative 21 and a negative 3 should give you a negative 24. So you have 2x minus 24 or 2x plus a negative 24. So there we go. Recall distribution and like terms. Now we're going to put it all together. So we're going to distribute and combine like terms, but we're going to also have to remember our multiplying rules too. So let's think about, I've got a factor or a number, a monomial sitting outside of a group here, sitting outside of a group that has addition and subtraction in it. So what do we have to do? We're going to have to distribute. So get out your pen. You can do the little rainbow marks. I'm going to have to multiply negative 4x times 2x and a negative 4x times 7. Now, a negative 4x times 2x. So think back to a couple days ago. Negative 4 times 2 is negative 8. And x to the first times another x to the first is x to the second. Negative 4x times a positive 7. Negative times a positive is a negative, and it's going to be 28x. And then this guy on the outside, this minus 3x just comes along. I'm working vertically. So I have negative 8x squared minus 28x minus 3x squared. Am I done? You might say, well, we might be done, but we might not be done. Are there like terms here after I distributed? And hopefully you're picking up that, yeah, Mr. Cummings, there are like terms. Here's negative 8x squared and negative 3x squared. They both have the variable situation of x squared. So they are like terms, and I can add them together to make it negative 11x squared minus 28x. Negative 11x squared minus 28x. And if you think back to last unit, are these two things like terms? They both have an x in them. And the answer is no, these are not like terms. These are not. All right, so moving forward onward. Let's try this one on your own maybe. Okay, on the outside of the parentheses here, I've got 4g, and that's multiplying all of this junk inside the group. So I've got to multiply a 4g times this term, a 4g times the 2, and a 4g times the d. All right, so let's just deal with the tough one first. That's this very first term. So I've got 4g times negative 5g squared h. And 4 times negative 5 is negative 20. If I've got a g times a g squared, that's going to be a g to the first times g to the second. The product rule says that that will be g to the third. I have 3 factors of g multiplying, and I also have an h in that term too. 4g times 2, very simply, 8g. And then 4g times d, keep track of the minus sign that's in front of it. 4g times d will simply be 4gd. Now we have to investigate our terms. Do any of these variable situations match? And this is g squared h. This is just 1g. And this is a g and a d. And no, none of them are perfect matches. So we are done. We cannot do any more. We cannot do any more. Remember, if you're to add and subtract some stuff, they have to be perfect matches. Their variable situation has to be exactly correct, exactly the same. Those are called like terms. So go ahead, try this one on your own. We're going to have to distribute an n and then combine like terms. All right, so work this one and see if you get the same thing I'm going to distribute that n. And I've got negative 3n squared becomes negative 3n to the third now with one more n. Minus 3n times one more n would be n squared. And then n times 1, anything times 1 is very simply itself. Yes, you could do 1n if you wanted to. Okay, but identity property said when you multiply by 1, it doesn't make any difference. Anything times 1 is itself. And then I'm going to bring down my minus 5n. That was not in the parentheses, so it does not get distributed to. Then you have to ask yourself, are you done? This is a term that has n cubed. This is a term that has n squared. They're not matches. This is a term that has 1n. We haven't found any matches yet. And this is a term that has an n to the first power as well. And hopefully you're picking up on, well, I can add plus n and minus 5n. And you have to think, okay, if this is a plus n, how many n's is that? Well, I think it's pretty clear. If you multiplied 1 times n and you got n, that literally is 1n. So I just added the 1 in there. So we have to add the n terms together. You got plus 1 and a minus 5. Signs are different. Take the difference. And that is going to give you minus 4n to the first. Now, these things all have n in them. But once again, those are not like terms because the dimensionality of the n's does not match. All right, last one here. Let's see if we can multiply 2w squared times, in parentheses, 3w minus 5t plus 1, subtract 14tw squared. Interesting. Go ahead, give it a shot. All right, so when I distribute, this is going to become 2w squared times 3w, which is going to be 6w to the third. 2w squared times 5t. Bring down my subtraction sign. This is going to be a minus 10tw squared. And 2w squared plus 1 is going to be just simply itself, plus 2w squared. And then minus 14tw squared, which is on the outside of the parentheses. Now I have to see, do I have any like terms, any terms that match and can be added together? I've got 1, 2, 3, 4 terms in this particular expression. See if any of them match. This one's w cubed. That does not match tw squared. Tw squared does not match w squared. But tw squared does, on the end, match this other tw squared term. So I've got negative 10 tw squared. And how do you know it's negative? Well, what is in front of the term? It's negative. You have to put your dividers up in between each one. That would be a good idea still at this time. So you got negative 10 tw squared and negative 14 tw squared. And you can add those together to make negative 24 of those tw squared terms. Now, you might have gotten a different answer, in a different order than I have, but as long as you have positive 6w cubed, check your expression to make sure you have 6w cubed. Make sure you have a minus sign in front of your 24 tw squared, and make sure you have a plus sign or just simply be positive on your 2w squared. If you have those 3 things, you have met the criteria for this. All right, and that'll be it for today. You can move on to the practice section, which I believe is 3.22, and ask me any questions if you have them. See ya.